welcome viewers. Today we're doing something a little bit different on my channel, usual from my DIY, welding, auto repair videos. Today we're going to talk a little bit about Logstash and setting up the ideal development environment for Logstash for those wishing to get started in Logstash. Before I get into how to actually set up an ideal Logstash development environment, let's talk a little bit about what Logstash is. First of all, it's a multi-protocol adapter. And what I mean by that is that it can accept messages from a wide variety of formats and sources. If you look at the Logstash documentation here, we have dozens and dozens of input plugins that are possible. All these different sources of data can be used to pull data in. Okay, dozens of them literally. And the most common ones probably, you probably be using is HTTP, maybe Kafka, and perhaps S3. So tons of different ways, TCP and syslog, all these different ways to get messages into Logstash. But once they're in Logstash, since it is a multi-protocol adapter, basically we're talking about transforming them and adapting it to a different protocol, a different output protocol. So you can take a look here. As many input protocols there are, there's likely just as many output protocols here. Okay. So imagine you can take an HTTP message and adapt the protocol into a file. So it'll be outputting a file. Or you can adapt an HTTP and send it over to Kafka. Basically, it's up to your imagination what you can do with it. Now, you'll be asking, in doing the adaptation between the protocols, can you also do transformations on the message? And the answer is, of course. That's what it's meant for. It's a message transformation framework as well. So you can use a Ruby language to transform your input message into some, you can augment the message, add additional fields, or delete fields in there, or completely change the format if you want to. So that you can do as well. But more likely than not, the reason why you come here is because you've probably been asked to, input messages from log output like syslog or analytics logs into Elasticsearch which is a NoSQL database. Logstash is the standard for getting messages from different protocols into Elasticsearch. Get into what I think is the ideal development environment. Has kind of several requirements, right? First, you need to be able to store your code and your configurations, which Logstash calls pipelines, in your source code control. Second, once you write your logic, you need to be able to test your logic in isolation. And what I mean by that is because Logstash inherently is a multi-protocol adapter, you're likely going to be deploying this pipeline within a complex system with different protocols. It could be very difficult to test your transformation logic without setting up an entire test environment with mocked up inputs and outputs. So in order to keep things simple, you need to be able to build something which allows you to test in isolation, something that allows you to test locally on your machine without needing to have all the infrastructure that the actual target deployment environment will typically contain. Next, you should be able to build a release from your source code repository. Once you are ready to take your project to the next level and deploy it into an actual test environment or production environment, which covers already off the bullet point here. You should be able to deploy it into your integrated test environment such that you will test not only your transformations, but you also test the protocol adaptation that occurs. And even more importantly, what a lot of people, what a lot of developers don't often look at when they start projects is how to transfer that knowledge to future maintainers of that project, right? Of course, the old thought is that, you know, keep the knowledge to yourself and you will have job security. That's a little bit old fashioned, and that's a sure way in today's world to get yourself um, not only uh, having the opposite effect is that, you know, your colleagues and other ones will surely hate you for keeping knowledge secret to yourself. And not only that, you'll be trapped working. You might have your intended effect of, you know, you only maintaining the code and you feel like you have job security, but while at the same time it will also block you from any new opportunities, and that is surely a very bad way to go, in my opinion. So let's get into it. So let's first take a look at what a typical Logstash pipeline looks like. I'm going to switch over to my AI assistant Copilot to generate me a Logstash pipeline. So first, generate a Logstash pipeline with input coming from standard in and output going to standard out. The filter transform should copy a field from the input called A into a new field called B. Okay. The input should be single line JSON and output is single line JSON. Let's see what this comes up with. Okay, so here we are. This is the most simple pipeline that we can create. So just gonna copy this. I'm gonna paste it into my my directory, my workspace here. So typical pipeline.conf. So let me tell you something about this. Now, while this filter probably will this pipeline will probably work, we have to think about most typically standard input and standard output protocols are typically used for test situations only. They're not really used in actual scenarios because nobody, you know, pipes in input from their console into a pipeline. You're most likely dealing with HTTP or S3 or FTP or something coming from a live system, some data coming from a live system. It's not going to be standard in, and typically it's not going to be standard out. So the only thing a pipeline like this can do is really, you know, be able to test in your local environment, right? But it's not a typical pipeline. But I wanted to generate this to show you the structure of a typical simple pipeline, right? And how, let's change this up a bit, just to give you an illustration, okay? I could go AI assistant instead of standard in as the input. Change the input to HTTP and change the output to Elastic search. And here it generates. And I'll paste it. Now all of a sudden you see that now it just got a little bit more complex to test, right? First, you need a HTTP input. You need something to send. In order to test this, you need something to send into the send HTTP protocol into this pipeline. And afterwards, you need an Elasticsearch cluster and an index of in there to be able to test your output, right? Now it's getting a little bit more complex, right? And I'd say, in a typical case, you'd be even more complex than this, because HTTP, although sounds like a very common protocol on the web, but in reality, a lot of the times, you may not even be working with HTTP. You may be working with syslog. Typically, a lot of legacy systems use syslog to output their logging, and not HTTP. So, getting a simulator to in the local environment for testing to send syslog is not that trivial, right? Testing your output, testing your transform, and by evaluating its output on Elasticsearch is not all that easy either, right? You got to log into Kibana or a UI in Elasticsearch, or you can write complicated scripts to query for what Elasticsearch has stored in its database, right? That itself is also complex. So I would say the typical structure like this, for a simple pipeline, makes it very complex for someone to run local testing. After all, in local testing, I'm going to try to convince you that the protocols don't really matter, the input and output. The majority of the logic, of your business logic, is inside your filter, inside your transform. This is what matters, and this is what you want to test, right? You can leave your protocol input and output protocol adaptation testing for integrated test environment, but testing locally on your own machine, your primary focus is on the filter, okay, and validating that your filter has executed correctly, right? So after seeing an example like this, how can we make it so that it's much easier to test in your local environment when you do have complex inputs and outputs? Well, fortunately, there's a feature in Logstash which I don't see it commonly talked about a lot, but what you can do is basically decouple your input, transform, and output pipelines. So in essence, you can create 3 separate pipelines, one that handles only the input, and one that only handles the transformation, and one that handles the output. So let's restructure this code, okay, into 3 separate pipelines, and let's chain them together that way. So let's put it this way. Rewrite this pipeline into 3 separate pipelines. One for the input, one for the filter, and one for the output. The 3 pipelines are connected using inter-pipeline communications. Let's see what it comes up first, okay? With this. Good. Okay. The AI has understood my request. Okay, so what this has generated is one input pipeline, right, which has no transform and it's chained to a filter pipeline, which has all the filter logic. And then you got a filter pipeline, which takes input from, which, it is basically starting a listener on the filter, is inter pipeline listener at this address. So you can see that from the input pipeline, this is sending to the filter pipeline, and so the filter pipeline is receiving filter pipeline, is advertising itself as filter pipeline, right? We do the transform here, and then on the output side, it's going to sending it to the output pipeline. And the output pipeline definition here is its input is advertising itself as output pipeline. And of course, when I say advertise, this is all inter pipeline communications within the Logstash system. It's not ports or HTTP or anything like this. This is internal to Logstash. How it's implemented, I'm not clear, but it doesn't matter for this point. So now we've broken it into 3 separate pieces. We can copy them and put it into our development environment. So come back here and create 3 separate files. Input pipeline conf. Just gonna paste it here. Like filter pipeline .conf. I'm gonna copy this. Okay. And then we're gonna put an output pipeline. Off. Okay, now it's all there. However, this itself will not run because Logstash, the runtime for Logstash needs to tie all these files together. And in order for Logstash to recognize all 3 pipelines in the same runtime, you need to provide a configuration file called pipelines.yaml, which define all of these, which reference all 3 pipelines and gives it a pipeline ID. Okay, so let's generate one. So generate a pipelines.yaml, which references all 3 pipelines above. We'll just copy that. That's all it takes here, right? So we'll put it in main directory. And we'll paste it. So 3 pipelines. Now note that it doesn't really know the path to your pipeline files. Okay, this is not a relative reference. Okay, it is if you deploy Logstash, the Logstash runtime in on your local machine in the traditional way. But I'm going to show you a way to do it differently, and a way that will fit within the goals of being simple to test and being able to transfer knowledge to maintainers easily. Okay, we want to avoid as much custom configuration as possible on a future maintainer's on computer. The more localized configuration that you need to do, the less likely maintainers will be able to pick it up, and also the more documentation you would need to write for this. So we're going to try to avoid this, avoid this problem by doing something which I'll show you in a second. Okay, now that we've got it into 3 separate pipeline files, that's great, right? I mean, however, it's still going to be complicated to test, right? You still need an Elasticsearch cluster, and you still need an HTTP input, right? So what I'm gonna do here is do something that will pull the transform out, allow you to test it locally, right, without using the output pipeline, right? And what I see a lot of people do in test environments is do something that I really don't like, right? They may say, oh, you might write an if statement here. If, which is perfectly legal, if dollar environment is equal to local, right? Then we do here, we do end here. I don't know the syntax exactly, right? But you say here, instead of doing an Elasticsearch output, we do standard out. And there'll be an else here, okay? Nope, that doesn't cut it for me. I don't like this pattern. You know, this it ends up having a lot of junk code in here that is not even useful during runtime. And this is how I don't recommend doing this way. Okay, the code becomes unmaintainable, bunch of garbage laying around in production code. No, we don't do it this way. So I'm gonna remove this. Okay, we don't put switches in productionized code like this, or we don't even do, you know, the alternative approach is you might want to do, you know, some runtime substitution on these things, or some compiler tricks. No, that's too complicated and for this kind of project, and you don't want to maintain additional tools just to do that pre-compilation. So it's not like it. Imagine if you had, back in the C++ or C days, you'd probably have an if def here, right? And an end here, right? And this is only if your environment, you know, was equal to local or something like that, right? And you have an end def, right? End def. And the pre-compiler would wipe this out if you're not in a local environment. If you're in production, it will use a different environment. We don't. This pattern is far too complex, and we don't have the tooling to do that. All right. So don't use this approach. Don't use if statements to control the logic here. Okay. Instead, we can use the tools that we're when given from Elasticsearch, and make another alternate pipelines file and an alternate input and output plugin. So what we do here is to organize this, put it in a folder, create a local test directory. And from here, we're not going to copy the filter pipeline, but we're going to copy the input and output pipelines here, put it into a local test directory. Paste, right? And what we're going to do is alter this one. This one, we put a standard in. Okay. The pipeline still goes to the filter pipeline. Save that. Output pipeline, instead of going Elasticsearch, we'll go to standard out. Okay. Alright, and of course we'll need a new pipelines YAML file, so we'll copy this one and paste it. Now we'll just alter this one. So it's still gonna using input pipeline, but it's gonna be using it from the local test directory. So whatever your path was to this file, we say local test. Now, on the output pipeline, we'll use local test. All right. However, because we're testing, we want to test the filter pipeline. We're not gonna put another copy of the filter pipeline in here. If you put another copy of the filter pipeline into this local test directory, you are sure going to have a divergence, right? A drift between the intended filter pipeline and the test one. Do not do that. Okay, reference the one that's in your root directory of this root directory of your project. Okay, so all you've done here is replace the input and the output pipeline, but you haven't replaced the meat of it, the transform. Okay, so that being said, after talking about this, let's get into how to run this project, how to get the Logstash runtime running and executing your local test set of pipelines. So before getting into running the test code and running the Logstash runtime, let's talk about what are the possible ways to do this. All right, and I'm gonna stick this under the knowledge transfer to maintainers point, because this is directly related to this. Now, option number 1, okay, download Logstash, install locally to your workstation. Okay. Number 2, okay, containerize this project and execute it within a container. Okay, so traditional approach, right? You download Logstash, the executable, the binaries, and you install into your local workstation and copy all these transform files into the appropriate directories and start the Logstash pipeline, right? With Logstash -f and given the configuration directory, right? Now you can do that way, and that certainly works, right? But I would highly advise against this, because when you do this, every time you do any kind of instruction you need to give to a future maintainer here, like installing Logstash, means there's a certain amount of variability that can happen, right? One, maybe you have to document the version of Logstash to install. You have to remember to export any variables or any path variables that lead back to Logstash. And not only that, in order to deploy all these pipelines into Logstash consistently, you have to write a script to copy it into their Logstash installation. That is more additional work, it's more documentation, and at the end of the day, it's going to be more confusion for a maintainer. Don't do it that way, okay? The second approach is the ideal one. Now, it may sound complicated. If you're not familiar with containerization, this may sound complicated, but I assure you this is really not. And this is the most ideal way, which will require the very least minimum documentation for a future maintainer. And you will see here, it is this is very easy. In fact, it's easier than number 1, right? So first of all, what you need to do number 2, right, is to download Docker. You must have Docker desktop installed on your machine, right? It doesn't matter if you have Windows or Mac or Linux. Get Docker desktop installed, right? And after you get the Docker desktop installed, right, you are going to run a base image which contains the version of Logstash that you intend to run in the target environment, right? So Elasticsearch publishes a whole set of versions of Logstash, and they're all available on Docker, the Docker Hub. So all you gotta do is create a Docker, is create a shell file here that will help you execute this project within the Docker container environment. So let me show you how to do that. So let's get into Dockerizing this this workspace, right? So basically what you need to do is get Docker to pull down an image which has Logstash installed, and what you need to do is get these files in your workspace copied into the Docker into the container, into Logstash, right? In order for to do that, let's write a command. I don't remember the Docker commands off the top of my head, so let's just use AI to generate it for us. Okay, so let's go back to here. Generate a Docker run command, which mounts the local directory or the current working directory into the container at usr share logstash dash pipelines. Okay, and will change the entry point of the container to this command, logstash path settings to usr share logstash pipeline. Okay, we generated this, and there's the explanation of what it does. Okay, so it's saying using, okay, it's using 7173. That's an kind of old version of Logstash, but that doesn't really matter. It works the same way. So let's copy this one, and we put it into our Visual Studio Code. We'll create a project right here. Sorry, we'll create a executable, a shell script right here. So it's called run logstash in Docker sh file. Okay, paste it here. I run a bash shell. Let's give this one a test. Okay, so we'll open our interactive terminal. Expand it. Give an executable permission, all plus x run logstash. So let's try this. Run. I ran this off screen and I realized I forgot something. I forgot the minus interactive command, minus IT, in this Docker run, because we are trying to get input from standard in, and in order for you know, the standard input to be directed into the container, you need the interactive input, right? So this terminal has to forward its standard into the container. Therefore, we need the minus IT as well. We need to go back and look at this one, the pipelines.yaml. Okay, because we're mapping our whole workspace into the Docker container, and the place we're mounting it to is user share logstash pipeline. We got to make sure that our pipelines.yaml file is corresponding with that, because if we're mapped this entire directory user share logstash pipeline, we got to make sure that this is the path here, right? Which contains that one there, and it contains the local, all these referencing the directory, because this whole directory will be built from this workspace. So therefore, if we're mapping it into the container as this base path here, it's the rest of this has to be relative to this project. That's the easiest way I can explain it. All right. So with that said, let's give this a try. Okay, run. Now this is kicking off. Now the output you're seeing here is actually coming from within the Docker container. It's not coming locally on our machine. It's actually executing within the Docker container, and the output is being displayed back to our terminal here. You see here all our pipelines, there's some warnings, but there's no errors. And the pipelines are running. There are 3 pipelines running. Now, let's give it a test. So because we asked it, to have a standard input, right? We can put our input here. And remember that we're parsing a JSON message here. I think the pipeline transformation assumes there's fields, and I think if you gave it JSON, it will understand that structure. So let's type into here in the single line JSON format. So we had a transform here that copies basically field A into field B, right? So we give it a field A in this input message. It's called hello world is the value. And close that off, and we press enter to submit it. And as you can see here, the transform went through because the output event not only has the field A, it also has field B, which is a direct copy of field A. So that's how we know that this transform and Logstash itself is executing correctly. All right, so we can try that again. The system will continue to listen to events. Right? Until until we kill it. Okay, we can do a control C and kill it. So that's where I'd like to leave this video off for now. Please, if you like the content of this video and want me to continue making them, please like and subscribe. In the next video, I plan to spice things up a little bit. We're gonna try to automate the testing of this pipeline. So let's recap what we've done here. We are setting up an ideal development environment for Logstash. So we've started with this basic directory structure, which you can store in source code control. And we've came up with a way to decouple the parts of the pipeline. You got your input, output, and the transform. The filter part of your pipeline. So instead of having one single file, we have 3. And the reason why we did that is because we wanted to decouple the input and output. Perhaps could be complicated input and complex output, such that when we're testing locally in isolation, we can replace those inputs with very simple ones. For example, standard in and standard out, while still being able to test our complex transform. Now this transform is very simple, but you get the picture. We could put a complex business logic in mapping fields and adding extra details. You can put a lot of complex business logic into this, right? And it will certainly need a lot of testing to do that. So it is very convenient to be able to map simple inputs and simple outputs, so you can do the validation, right? And we also talked about a very important point on how to actually run Logstash, how to run your pipelines locally, right? We have a choice between installing the Logstash software, where it would involve finding the particular version that you want to run of Logstash, download the binaries, unzip it, configure the directories, copy over your pipelines. You probably have to script that in order to get Logstash to run, which is not ideal. We've chosen to do it this way, is to instead containerize it, right, and basically have Docker start up a container with a particular version of Logstash and map our local directory, our workspace, directly into the container, and basically override the configuration directory, the entry point, right? So we tell it to look for USR share Logstash pipeline local test, right? Which will look for these pipelines, right? Logstash is really looking to this directory to find the pipeline's definition file, this YAML file. And when it sees this, since all these files are now mapped into the container, it will be able to find it and execute it. And that's why we were able to do this. Now, this is the basis of the ideal development environment. There is more reasons that why we should do it this way, and I'll get into that in future videos. But if you like this video, please like and subscribe. In the next video, we're going to spice things up a bit. We're going to actually develop a very, very simple automated test framework where we can entirely automate the unit test of your filter pipeline, all within this project. So stay tuned. Thank you. See you next time.